I'm going to give you a quick overview of the games development courses at the University of Central Lancashire. So yes, welcome to Games Development at UCLan. My name's Laurent Noel. I'm the course leader for Games Development. My email is there in case you have any questions after having watched. So, quick overview of what I'm actually going to be talking about in this presentation. First, why might you want to study games development and what does it involve? I'm going to talk about our own games development course here at UCLan, which has been going for a long time and has won quite a few awards. I'll be talking about the staff involved, including myself, a games industry veteran. I owned my own games studio in the past. Give you some details about what you'll actually be doing on the course and briefly talk about what kind of careers you can expect in the games industry. So games development itself, before I talk about our course specifically and why you might want to come to UCLan, I want to talk a little bit more about the games industry. I come from the games industry originally, and it's a huge industry, which perhaps a lot of parents, for example, may not quite realise exactly how large an industry it is. It's the turnover of the games industry larger than the film and TV industry combined, and has been for many, many years. The larger titles, which we typically call AAA titles, require teams of tens, hundreds of developers and budgets in tens of millions or even hundreds of millions of dollars. Now, when creating a game, there are typically technical roles and creative roles, or if you want to split them simply, programmers and artists. Of course, there's some management to the side of that, but for the main development roles are programmers and artists. Now, this is a really important point you need to make before selecting a games course. Do you see yourself as a technical person or a creative person? Are you going to be a programmer or an artist? Because I can speak from long experience, there are really no roles for people who can do both. Either you're a programmer or an artist. And you'll find the courses also tend to shift between, focus on one or the other of the topics. So the games development course at UCLan is for programmers. We're going to teach you software engineering for games. Now, if you're interested more in the creative side of games, you should have a look at our games design course, which I'll mention briefly in a minute. And also, if you're looking at any other courses at universities elsewhere, we'd love you to come to UCLan, but if you do look elsewhere, make sure you go to a course that actually covers the topic that you're interested in. If you feel you're a programmer, make sure that the course you're looking at covers a lot of programming stuff. Please avoid any courses that try and do a little bit of both, a bit of programming and a bit of artwork, because that will make you half as good as you should be in both of those areas, and you'll find that you're probably stronger in one area than the other anyway. And you'll just find yourself actually trailing when it comes to those job interviews afterwards, when when you come up against someone who's actually more specialised in the area. So, if you feel you're a programmer, then ours is the course for you. Software engineering for games. Now, because it's software engineering for games, that means we're going to teach you a collection of software engineering skills that are transferable to pretty much any career in computing. So even though, and I'm talking slightly to those parents right now, that even though this has the word games on the tin, this is not 3 years of playing games. This is 3 years of learning software engineering for games. Games are enormous, real-time interactive programs. We see the obvious things we see when we're playing a game, or the character picking up things and earning points and shooting other people, and that might all seem a little bit not particularly complex or career-worthy, but actually in practice, the modern games developer now builds worlds. We expect these in a AAA title, we expect huge worlds fully populated with every blade of grass reacting to our footstep going through them, every can of Coke we can kick around and responds correctly in the physical way with the environment. So a modern games developer really is creating worlds for the player to inhabit, move around and do things, and that's very complex. It involves a lot of very, very technical software engineering. And we pride ourselves, UCLan, on our technical expertise. We are our teaching team are all software engineers. Myself, I'm a very experienced technical director from the industry itself, and we've won many, many awards for our graduates and current students. In fact, this year we won Games Programming Graduate of the Year and Best Current Student of the Year. We won both of those titles this year, and we've won that 7 times in the past. So we pride ourselves on being a technically complex course. And yes, I said the word complex there, and that's an important point. This isn't going to be 3 years of playing games. This is going to be 3 years of programming games, and that is a challenge. We will give you the skills that will get you into the games industry and be programming the AAA titles of the future. But don't expect that that's just going to be all fun and games. This is is a serious degree that leads to serious jobs. So who are the team? Well, there's myself. My name's Laurent Noel. I used to have my own game studio. Before I came to this course, I was owner and technical director there. I've given jobs to many hundreds of developers in the past, so I know what I expect of someone coming out of university, and I know what I'm looking for when coming into a career. My particular specialism is 3D graphics, and I pioneered a lot of the 3D graphics we see in computer games these days, and particularly was a pioneer in motion capture. Some of my earlier games were football games. You can pretty much blame the FIFA series on me, although I did games that were even prior to that, and we pioneered all the motion capture and 3D graphics that was used for that. Also did quite a lot of virtual reality work in the early days as well. Since then I've gone into world building, open world games, and so on and so forth. I've sold up that company and then set up a technical company that was doing technical work for the fashion industry, and so sold that company, and then helped the original course leader of this course bring this course together, and now I am the course leader of this course. So a lot of experience. I think I've sold over 2 million games in my history, so I know exactly what the games industry is looking for. Now, who helps alongside me? Brendan Cassidy, an expert in modern gaming technologies. He's particularly focused in virtual reality, augmented reality, and that's something we actually get quite a few students to work with, particularly on third-year projects. We also have Nick Mitchell, who's an ex-BAE software engineer, and he's an expert in team-based advanced software engineering, because these games are built in huge teams, and we do need to be great at working at teams. So a team, I see a collection of very, very experienced software engineers there to help deliver this course. Of course, there'll be other people delivering other aspects of the course. Those are the main three you'll see. What courses do we have? Okay, the main course is the BSc in Games Development, and that's for games programmers, as I've already mentioned. It's a 3-year course, and there's an optional placement year between the second and the third year. Now, if you are interested in game art, we do have a BA, an arts course on games design, and you should go back to the website and have and search that one out, because if you're in the creative side of things, we're not going to do any creative content at all on the Games Development course. You don't need to be an artist, you don't need to be able to draw whatsoever. If you want to do games development, you need to be a programmer. If you are more the creative kind of person, go and have a look at our games design course. They also have a lot of industry experts, and it's a great course. We also have an optional master's, an MComp, which adds a 4th year on the end of the 3-year course, and that's designed for those who want to be the best in the field. We had quite a lot of feedback from the studio saying we really want to separate the best from the very best, really separate the top end and work out who are the greatest graduates coming out. And so we added this extra MComp, and I brought in some commercial grade programming. Didn't hold your hand anymore. It's literally the level of programming you would expect at the highest echelons of programming within the games industry. Some cutting edge technologies, like ray tracing and the like, recently, for example. At the other end, if you don't have the grades to enter our degree program, we have a foundation entry year. That's like a year 0. So if you don't quite hit the grades you want, or if the course you're doing right now doesn't quite lead to the grades that we need, you can try our foundation entry year, which has slightly lower entry requirements. You effectively do a year 0, does a bit of programming, bit of study skills work, and then that gets you into the degree proper, and then you can continue with the Games Development BSc just like any other student. So those are the options for you. More details on the website of everything I'm talking about here, and of course bring questions if you want to our live Q&A on Monday, Tuesday. Very briefly going to go over what modules we have on the course. Now, there's an important thing about our first year, and these are the modules that you'll cover, but we have this common first year, which means that enough of this is common with our other computing courses that if you wish, at any time up until the end of the first year, you can transfer to any of our other computing courses. So imagine you started on games development, but actually you found the programming really nice, and maybe you didn't want to specialise in games. You could just switch over to software engineering, or maybe you like the idea of the security stuff we studied in that last module you'll see there, so you could switch over to our cybersecurity course without any loss at all. So at the end of the first year, you make a choice: am I going to continue with the course I've chosen, or do I want to transfer onto any other ones? And we've got computing, networking, cybersecurity, cyber forensics, working with the police and the like. We've got software engineering, computer science, as well as our games course here. So a wide range. You're effectively doing multiple courses at the same time, and you can pick and choose all the way up until the end of the first year. So what do we have in the first year? The first thing you do is a 4-week introduction module to introduce you to studying and computing and getting a flavour of a bit of everything. It also helps accelerate introductions, and you can meet some of the people you'll be your fellow students and work with them. So we've put you in small teams, and you create an app, and there's a bit of security in the app, there's a bit of programming in the app, there's a bit of marketing in the app. So there's a little bit of all the various things you might need to do, and by the end of 4 weeks you've kind of got yourself settled into the university, met some mates, produced an app that's already working, and passed your first module. We found this is a really good way to help introduce that kind of slightly worrying period at the beginning of the university. Once you've completed that, you kick on with the main 5 modules for the rest of the year. Games Concepts is a special module just for the game students, where we give you a simple game engine that we've programmed ourselves, and you can use that game engine to produce some simple 3D graphics and build your first games. We use a game engine that we've built ourselves because in later years we'll show you how that game engine was put together. A lot of games courses do quite a lot of work with Unity. I don't know if you've heard of that. Unity is a game engine which you can use to make free games, and it's a lovely package. We use it a little bit ourselves in the second and third years too. But we actually in the first year prefer to give you our own engine, because then we can pull it apart and show you how it worked later on, which is something you simply can't do with Unity. At the same time as doing that Games Concepts module, we'll give you some introduction to programming. We'll introduce you to some C++. C++ is the language of modern games. Now, bear in mind our games course is for PC titles and AAA console titles. We are not developing games for mobile phones or web-based games. This is not the focus of this course at all. We're looking really at the big AAA titles that we all know. Now, the language that's used for all of those titles is C++. C++ is a language that's very high performance, can produce the very high quality graphics and very complex environments, and it has more performance than many of the other languages. Every studio that we've communicated with, and of course myself when I ran my own, knew that what we wanted most of all from a graduate was as much C++ experience as you can possibly have, and that's what we do right from the beginning all the way to the end. You'll be programming in C++ to give you that maximum C++ experience. Be wary of any courses that teach in other languages like Java, for example, because that's not really a language that is used in the games industry at all. And computer systems and security, very important, looking at the hardware of computer systems, but more importantly the security of modern systems, relevant in every single field of computing these days. So that's the first year. If you choose to continue with games development, and I hope you will, it's fun, we'll go into the second year, and we have the first of module is Games Development 1. Now, we've given it that generic title because there were a lot of smaller topics in games that we needed to bring together. Use of game engines like Unity. We do introduce the Unity. This is a picture of Unity going there. We introduce Unity. It's a game engine that allows you to put together quite complex scenes and characters in those scenes and have them animate and walk around and do things and interact with the scenery quite easily. There's a certain amount of drag and drop in it. There's a certain amount of programming in another language called C# that we'll also show you. That's really quite powerful to understand how to get the game mechanics working, how the game plays, what happens when you do this, and so on and so forth. We do a certain amount of that. We don't do too much of that. If you want to separate our course from other courses, understand that we do less Unity than other courses quite deliberately, because we want you to learn to do things yourselves. By the end of our third year in our master's course, many of the students could write their own engine. Not at the quality of Unity, but certainly they can write a complete engine on their own from scratch. Whereas a lot of courses that focus almost entirely on Unity, the students come out a little bit lost if they don't have this package ready to already, to help them along the way. And the problem with using a program like Unity is it provides a lot of really powerful features for you, but you didn't write them yourself and you didn't know how they worked. So there's a very large amount of very high complex technology that you don't understand if you just use Unity all the time. So we try and deliver that material to you as well. However, we do use a certain amount of Unity to help you learn some of the gameplay aspects of things. We'll teach you about game physics within Unity, how to get sound effects up and running. Artificial intelligence is a key element within games. We've probably all been frustrated by a game whose intelligence isn't quite as good as it should be, but we'll show you the basic mechanics. how to get a character from A to B within a complex environment, how to do team-based thinking between characters in a game, and allies and enemies. So we have a certain amount of artificial intelligence introduced there as well. So we bring together a lot of smaller topics within this Games Development 1 module. Then we have this computer graphics module. That's not about drawing graphics. That's not about us being artistic. It's about the technical aspects of creating graphics, light and shadow, and how that's worked. These days, you can see in the small picture inside this Unity, there's a lot of shadows being cast around, and if a character walks around there, they'll also cast shadows around. We can't have the artist draw that all in advance because they don't know what's going to happen, so we have to cast every shadow, reflect every little glint of light, needs to be programmed, and so the computer needs to know how light interacts with matter, how shadows are cast, and that's what computer graphics is about, how to visualize the world. So we'll be doing some programming in DirectX, and we'll write shaders. You may have heard of pixel shaders or vertex shaders maybe in your knowledge of games. Whilst we're doing these very, very games-related things, we'll also do lots more programming. Software development is about the team side of programming, the testing, the kind of what we call the softer side of programming. It's not actually the coding side, but the planning and management of programming, which is very important if you're creating programs in teams of 100 or so. We'll also do some more advanced programming in C++. This is a C++ module. And computational thinking is thinking about complex problems and breaking them down and working out the best algorithm to do them. It's very, very linked to programming, but it's more taking a step back and trying to work out the most efficient way of solving a problem, which is important. Modern games are very large, and we need efficient algorithms to manage them. The Agile Professional is also linked to all of those, and Agile is a methodology of working in teams. Which is the modern way that most software engineering is done these days, and certainly in the games industry. And one aspect of this particular module is building a large game in a team. And you will actually produce a game in the second semester there, which is complete. So, moving finally into the third year. And now, to keep this particular presentation brief, I'm not going to talk too much about placements. Ask us about that in the question and answer if you like. But between the second and third year, you can take a placement out. We can't guarantee you a placement in the games industry. No course can do that. But we have regular placements in the software engineering industry and a number of placements in the games industry, usually every year. But you have to apply for them like you apply for a job and beat the competition. However, our students are very well prepared because we have a very technical course, and so usually our students look very, very well prepared compared to students coming out of the second year of other courses. So you may have had a chance to spend a year in industry before you came into the third year. And coming into the third year, the first thing you need to decide to do is what would you want to do for a double project. Now, almost all degree courses have some kind of third year project, a final year project, and it's pretty much the most important part of your entire degree. It's worth 2 modules worth, and it's going to be the centerpiece of your CV. How do you get a job in the games industry? You show them a couple of programs of you've written yourself that show some game technologies or a game or some graphical technique working, and your double project is something that you think will sell yourself to get yourself a job. You can decide what to do, and it could be an artificial intelligence thing, it could be a full little game, it could be a mini game with physics involved, it could be a visualization like this. This is a bit of ray tracing, which is a very modern way of drawing things these days. This is a little physics simulation of a piece of cloth. Maybe you could do something along those lines. In practice, this is actually part of one of the other modules, so you couldn't do that. As well as a double project, we'll give you advice about what to do, and you can choose to do there. But whilst you're doing that project of your own, we'll have a couple more modules for you to do. Games Development 2 continues with what we saw in the last slide on Games Development 1, and we'll give you more experience in various topics around the games industry. We tweak that depending on what the needs of the industry are, and because I am myself a technical director previously, I know what currently is involved in the technical aspects of games, so we keep these up fresh. And this is also a similar one, Maths and Technologies for Games, which is the very, very latest techniques that are being used on PCs and consoles. Now, wait a minute, I said that word maths. I imagine some of you probably aren't too fond of maths. Maths and games development are vaguely related. There is some connection there. There are some aspects of games development that involve maths. This is a physics simulation that's done as part of that module, and this is simulating some cloth. It's not going to be shown to the user like this. This is a collection of springs and weights that will move around in the wind, and that could be a flag or the sail of a ship or just a pair of curtains in a house. We have to create worlds that are so realistic these days that every trivial little thing needs to behave the way you expect it to do. So even simple things like making curtains billow in the wind, we have to do properly with full physics simulation. simulations. But the physics involved here does involve a little bit of maths. So for those of you who like maths, there are topics like physics where you can really have a let loose with your maths knowledge and take that in further directions. Water simulation gets quite mathy, for example. However, for those of you who don't like maths, you can edge around the topics that are a little bit maths heavy. So we try to make sure that those who like maths have something to do, and those who aren't too fond of maths can do those topics that don't involve maths so much. So don't be too scared by that word, or look forward to that word if you're that kind of person. One of the interesting things about this module is I take requests for content. If there's something you've seen a game do and you'd like to know how to do it, I'll research it if I don't know already, and I'll show you how to do it for yourself. At the same time as you're doing these, we'll do object-oriented methods in computing, which is more C++, so essentially it's more programming. Finally, you get one option in the third year where you can choose one of these two. Now, we don't focus on apps or internet games in the main. However, the majority of games do get an app version or a mobile version, so it's useful to have a little bit of side knowledge in that area, so we offer you a little bit of side knowledge. You can either go down the mobile route or the internet route, depending on which kind of side you're particularly more interested in. Now you can finish at that point with a BSc. If you otherwise, and I've not put a slide up for this, if you want to take it a bit further, you can do our master's course and go into a fourth year where there are 2 taught modules that are as advanced as we can make them, and they're pretty much leading directly into senior programming level in the industry. And you do 2 projects, a team project and an individual project, and we'd rather hope you'd publish one of those as well in the master's course. At any time you can switch on to the master's course if you so wish, if you want to take it to that extra 4th year. How does this all actually work in terms of learning and assessment? Well, most of those modules I talked about have 1 lecture in a week and one or two practical sessions in that week as well. You'll find that about roughly 50%, if you're full-time, about 50% of your time is going to be in class, be it in a lecture or in a practical, and about 50% of your time is self-study. This is pretty similar across all universities and all courses. You're usually in for 4 days of the week in the university. There's usually 1 day when you're not in the university. Wednesday afternoons are set aside free for sports and activities and clubs and the like. There's lots of university clubs. Typically, most modules have 1 assignment, which you do in your own time, a bit of coursework, and 1 exam. There are a couple of modules that only have assignments, so there's a little bit of exam work and a little bit of assignment work, slightly leaning on the side of assignments in the main, as it is largely a practical course. We're used to all kinds of special needs. If you do have special needs that mean you need exams done in a particular way, or any other support like that, do talk to us. We're really good on that kind of thing, and we can make all kinds of special exam and class arrangements. I think one thing I haven't mentioned in any of the slides here is our course has been running for, I think, 15 years now. I think we're just entering our 15th year, so we're a very mature course and we've dealt with all kinds of situations. So, yep. Research. Don't forget we are in university, and we do research. People often think about university as getting a course and getting a degree, but we are all research active. A couple of things in the games area that we're research active. We do quite a bit of virtual reality and augmented reality rendering. My colleague Brendan has done quite a lot of work in the VR field and different uses for virtual reality and augmented reality. I'm more interested in the technical aspects of it, implementing virtual reality efficiently and how to reduce the user discomfort, which is a real problem for games. Some things like first-person shooters don't work but can cause problems, can cause kind of motion sickness in VR, and we're trying to try and minimise that so we can get the best out of VR. On a completely different topic, I do quite a lot of astrophysics research, which you might think, what's that got to do with games? Well, I visualise galaxies and galaxy clusters using game technology. This is a screenshot of a very complex cluster of galaxies. It's from the early universe. And we're using the same graphics technology to draw that as we would for an explosion in a game. It's basically a particle system. There are 100 billion stars in that simulation. There's cross-university links. We have a very strong astrophysics department, and we work with them. And I've actually had game students working with the European Space Agency, because some of the work that I do here is with the Gaia satellite, which is mapping the Milky Way right now, and we've been visualising that. And I've actually had students from the games course, undergraduates, working with the European Space Agency. So don't forget that we can, research is a thing, and you can get involved with that even when you're an undergraduate. Careers. I used to have a slide that had all the companies that our students have been to, but frankly it's pretty much every studio you can think of. Because we've been going for 14-15 years now, and we have about 40 students a year, so we've had a lot of our graduates obviously have gone out into the games industry. What that means is most of the places you go, there will be or will have been a UCLan graduate there before, so it gives you instant credibility when you apply for games jobs. Some of our recent graduates are International Product Manager of Capcom is ours, so he manages all the international the whole product lineup for the entire of Capcom. We've got lead developers, senior developers, gameplay programmers, graphics programmers, AA programmers, and even games designer. So the whole spread of possible areas there. A quick word about games designers, because I know I get some people coming to open days who are interested in games design. Bear in mind that games design is not a role that graduates go into. We're all well aware of some famous games designers who have done some great games. You don't walk into that kind of job from being a graduate. Being a graduate, you go into an art job, or you go into a programmer job, and then you work within the studio, and at some point you might gravitate to being a specialised games designer, and you can become a games designer via the programming route or the creative route. Either way can lead you to games designer. You don't go straight there, but we do have some of our ex-graduates have now gravitated into the games designer role. Every year, the UK's leading games recruitment agency runs Search for a Star, which pretty much all the games development courses enter, and it's to find out who is the best games graduate and who is the best current student for that year. There's lots of technical games and development tasks, tests and interviews. There are several parts to it, by the way. There are some art sides to it, but there's one of the competitions. The one that we enter is the programming one, which is broken into technical games development tasks and interviews. This year's programming winners were both our students. We won both parts of it. There were only 2 parts, and we won both parts, and we've won 7 times in the past. In fact, we usually have the highest number of students in the final rounds of this competition every year, and that's because we take a very specifically technical approach. A lot of the other courses focus a lot on Unity, and that means they're great at making Unity games, but they're perhaps less strong at programming. We focus on Unity and a lot of programming, and that means typically our students are technically very, very strong. And often go straight into senior development roles, and that means we win this quite a lot. And one of the great things about entering and winning this is you pretty much immediately land a job. So this year, one of our second year students, just a second year, won the best current student. She did an amazing procedurally generated game, and one of our master's students won the best graduate, and he's obviously walked directly into a job, as I think all of my master's students this year have walked into jobs. So that's careers, awards, it's all good stuff.